This right here is the traditional Tesla transformer, secondary, wound with a thin gauge wire on a insulative cylinder. This right here is the primary coil, which is the source of the electromagnetic energy that causes the surge of voltage in this coil. The problem with the traditional Tesla coil is it works like a bell, like a church bell. A clapper hits the bell, it resonates, but once the clapper hits the bell again while it is still resonating, it extinguishes the existing resonance and then gives it energy for the new resonance. So this twofold action of the clapper keeps the loudness of the bell at a certain level. You cannot ring it infinitely loud. You may destroy it by hitting it very, very hard, but you cannot add resonance, add oscillations, add amplitude to the already existing wave. So you hit it, because you hit it at a random time, the chances are that you will produce constructive interference are very low. So your clapper hits the bell at a random time. A bell is already ringing, so you hit it, you extinguish the existing ringing, and you cause it to ring again. If you pull the rope harder, your clapper strikes the bell more, gives it more energy, and it resonates louder. And this is where I believe information about real Tesla research was lost, is that Tesla using his analog primitive methods of the late 19th, early 20th century, was able to do what this circuit right here does using today's methods. This circuit measures the oscillations of the secondary, and when amplitude sinks below some level or some amount of oscillations happens, there has to be two options for different research purposes. This system adds a pulse to the primary in such way that it doesn't extinguish the already occurring oscillations of the secondary, but causes constructive interference. So in a way, you strike the clapper of the bell with very precise timing, and this is why we need a processor here that oscillates the crystal. The clock should work at a frequency probably 100 or more times higher than the Tesla secondary oscillates, in such a way that we can position this pulse right here from the capacitor bank using this electronic trigger mechanism, this control device, either solid state or spark based, and we trigger this, the primary, in such a way that the secondary that is already oscillating is getting a new boost. It causes constructive interference instead of destructive interference or something in between, and energy in the secondary keeps building up. So this principle was proposed by many hobbyists, but there's no half-assed cheap way to do it. You either have to build a process or not do it at all, because when electronic phase locked loop systems are used, analog electronics, they would strike this every time this oscillates. And no, it cannot happen. In the Tesla coil, the primary operates at lower frequencies than secondary, where you will have tremendous losses. So you strike, you wait, you position your new pulse, and then you strike again. It will be nice to include an oscilloscope and many other analytical instruments can be used for research. Of all things, this system may be used to test free energy claims associated with the Tesla transformer, but it may also be used as a metal detector, because properties of this system, if there's an antenna, will change if some metal in the ground is detected. This system can be used to detonate mines, to extinguish landmines. The system can be used for many researches because it's self-tuning. The property of the RCL resonator, the secondary coil, will change, and this can be tracked, and some analysis can be obtained this way, some scientific results. Yes, both of those systems, all those systems are RCL resonators. There is a capacitance between windings in the Tesla transformer, the secondary. There is a capacitance between several windings that it has in the Tesla primary. Everything, including the wire, has its RCL properties. So capacitor bank here, I did not draw the return path, energizes the primary. Current surge goes through, it all returns to through the ground or through another specialized conductor to the capacitor bank, and this resonates. Then the resonance decays over time. So there's an important moment when this system has to find the right moment to position a new pulse, including all the delay that this system generates. Strikes the primary coil again and adds to the resonance of the secondary coil